The thermal physics assignment question 20. In this question, the maximum recommended temperature at which a meat should be maintained when it is being transported, that is 4 degrees. 275 kilogram of a meat is being transported to a supermarket. The meat is cooled from 18.5 to 1.5 before it is loaded into a van and ready for transportation. The specific heat capacity of a meat is 3.59 into 10 to the power 3 joules kilogram inverse Kelvin inverse. Calculate the amount of thermal energy being removed. So whenever there is a change in temperature, the energy, there are three formulas of energy which we use. If there is a change in temperature, E is equals to Cm delta T. If there is a change in state, E is equals to M into L, latent heat. And if we use electrical heater, that is power into time. In this question, there is a change in temperature. That's why we'll use the first formula. So E equals the specific heat times the mass times the temperature change. So we can say delta theta. The specific heat capacity, it's given for the meat. The mass is 275 kilogram. The specific heat capacity, that is 3.59 into 10 to the power 3. And what about the temperature change? Remember one thing, that temperature change in degree centigrade is same as temperature change in Kelvin. So if I'm finding delta T, I don't have to convert or change the units because the temperature change in degree centigrade is same as temperature change in Kelvin. If I need initial or a final temperature, in that case, I have to convert. But right now, if I just work out the difference in the temperature in degree centigrade, it's same as the Kelvin. Because to convert into Kelvin, I will add 273 here and I will add 273 here. And when I take the difference between them, it will be same difference. So it won't be an issue. Whenever you want to substitute a temperature change, no need to convert the unit. Just take the temperature change in degree centigrade. That is same as temperature change in Kelvin. So E is equals to Cm delta T. When we multiply them, this will give us the total energy, which is 1.68 into 10 to the power 7 joules. That is a total energy. That is a total energy which is being removed because we are reducing a temperature. That's why this energy is the removed energy. If the temperature increase, then it will be a supplied energy. In the next part, when the meat is unpacked at a supermarket, it's initially left in a warm environment. The meat warms up uniformly from 1.5 as energy is transferred to meat from the surrounding at a rate of 720 watts, like 720 joules in 1 second. Show that there may be a risk in eating the meat if it is left out longer than an hour. Like if we leave it more than an hour, the temperature, it won't be suitable for eating because as I mentioned, that for a transportation, the meat temperature should be 4 degrees. If its temperature increase 4 degrees and left, so the final temperature will be higher than 4. So we have to find first the final temperature and then compare that whether it will be suitable or no. Or the temperature change we can also calculate. And from temperature change, we can work out, for a temperature change, we can work out the final temperature. So again, using the same formula, E is equals to Cm delta T. Now, whenever, like example, we have a power and time is there, so energy is power into time. So P into T is equals to Cm delta T. We will find the temperature change, and from temperature change, we'll find the final temperature. So P into T divided by Cm is equals to delta T. P is the power, which is 720. The time, it's like 1 hour. We multiply by 60 to convert into minutes, and then multiply by 60 to convert into seconds. Divided by the specific heat capacity of the meat, which was given in the first part, 3.59 into 10 to the power 3, and the temperature change for the meat was 375. So using this, we work out a temperature change, which is 2.6, about 2.6 degrees centigrade, or 2.6 Kelvin, if the units are in joule per Kelvin, so it will be in Kelvin. So temperature change by 2.6. So as a result, what will happen? As you can see, the temperature change is 2.6. So if the initial temperature, it was 1.5, as we know, the temperature change is final minus initial. The temperature change is 2.6. The final temperature we don't know, and the initial temperature is 1.5. So when we solve, we find the final temperature, it will be 2.6 plus 1.5. So the final temperature will be 4.1 degrees centigrade. Means that will be above 4. So it won't be suitable to eat this meat, as the final temperature or the temperature is above 4. Because in the beginning of the question, they mentioned the temperature of a meat should not exceed more than 4 degrees. Otherwise, it won't be suitable to eat. So you will work out the final temperature, like temperature change first, and then the final temperature, and compare this final temperature with the maximum temperature for suitable meat. As the final temperature is higher, so that's why there is a risk of eating this meat.